All right. First thing we're going to do is graphing intercepts and asymptotes. As a reminder, we're recording. As a reminder.
Oh my god.
So P over Q decides what type of asymptotes you have. If it is P is greater than Q, and when I say greater, I mean the highest power is greater, then that is going to be no asymptote unless it's exactly one higher. So if it's exactly one higher, then it's going to be a skewed asymptote. And that only happens when it's one higher, so plus one more. If P equals Q, let me put a A and a B here, then it's going to be the coefficients. So it's just going to be A over B. Your horizontal asymptote would be A over 2B. And if P is less than Q, aka the bottom's bigger, then your asymptote is going to be 0.
How long are flares high for?
All right, so for this one, number 1, the bottom is bigger. So this is going to be a horizontal asymptote of 0. Vertical asymptotes, to find the vertical asymptotes, you set the bottom to equal 0. So Q, you set the bottom to 0. So x squared plus x minus 2 equals 0. I don't know yet. X minus plus 2, x minus 1. 1, negative 2. So you have a vertical asymptote at 1 and negative 2. So 2 left, you have a vertical asymptote here. 1, vertical here. And I should do the horizontal one over here. X-intercepts, so where it hits the x-axis, you make the top equal 0. So P equals 0. In this case, it happens at 1 or negative 1.
Oh my god. Oh my god.
Why would you turn the faucet on?
I didn't know what happened.
You know what's funny? Somebody else told me they did that too. And I don't understand what drive people to be like, let me just turn on the water.
Do you want a cup? Do you want a cup?
There's.
You have a cup?
Yes.
Oh my god.
Wait,
This
did
for
you
you?
like this?
This for you?
What? No, you got it.
Did you clean it? Sorry.
So then, x-intercept is negative 1. So we hit the x-axis at negative 1. You set the top equals 0. Let me use purple to make it clear. The y-intercept is you set x equals 0. So you're plugging 0 for all your equation. So it's going to be 1 over negative 2. So that's a negative a half. Negative half is over here.
Apparently, her husband is tall and dark.
Guys, can I?
So you saying he's
I thought that was
a great guy?
So, what you're going to do is graph the thing. The best way to do it is to plug into your calculator. I'm going to graph it very quickly. If I do it correctly, I believe it looks like this.
how much longer flares can be high for?
But you can type this as a calculator. I'll show you how to do that.
The finals Wednesday?
So if you want to type it into the calculator, you go to y equals. Remember to use parentheses in these situations. So the top part is x plus 1, while the bottom part is x squared plus x minus 2.
It's not why. It's because it's like more, like there's more demand. So they're like, why not raise?
Minus 2.
They're not traffic. They're not raising.
So I got the right shape of it, but again, use your calculator to do the hard work, which is the curved part, okay?
Oh my god.
All right.
It's a bigger demand for cars. It says traffic for cars.
Next one. Sam, any question or no? Okay. Next one. In this case, P equals Q. So the horizontal asymptote is just the coefficients. So the horizontal asymptote is at 2 in this case. The vertical asymptote is when the bottom equals 0. So when Q equals 0. So in this case, it's going to be x equals 0. So let me actually graph these. So horizontal asymptote at 2, so up 2. And a vertical asymptote at 0.
Wait, why is the horizontal 2?
It's the coefficients of the biggest exponents. So 2x minus 4 over x. So in this case, it's here. We cross this out, which is just the numbers in front, 2 and 1. You just take the numbers in front of the biggest coefficients.
So for the other one you had, why is the horizontal?
Because that one, the bottom has an x squared while the top is just x. Which that means that it's automatically 0. That's a q is bigger than p situation. This only happens because p and q are exactly equal. Remember, it's like we're putting an imaginary infinity, so where the other parts get scaled out. All right, x-intercept, that's when you make the top equal 0, so p equals 0. So 2x minus 4 equals 0, so x equals 2. So we know we're going to hit the x-axis at 2 over here. And then the y-intercept is when you put x equals 0 for the whole equation. But in this situation, you'll get negative 4 over 0. So there is no y-intercept.
You're gonna go into the wall with that shit. People are gonna look at you like you're fat. Actually, 1, 2, 3, 4, 5, 6, 7, 8, 9.
She's just assaulting and bullying me right now, which I don't understand why.
You should have worn that on the final.
17.
I guess I am. All right. So for this one,
That's such a good that would
Abby,
be
look
our
at
cheat
the
sheet.
look at the board.
Abby, I do my best.
next one, logs.
Guys,
Video
it's
back.
on the recording.
Yeah, sure. And also, I did not go over every version here. This is just what I gave you on the test.
Oh, so
But
we don't have the one that. Wait,
It could be that, it could be skewed. So I would say suggest use the old video I made for the test, which probably went over every version.
Wait, go to the other one. Go to the first
It was like the diagonal one.
Can you go to the first one?
No. It was like the asymptote was diagonal.
Can you go to the first one, please?
Again, look at the old video for that because I don't have a one ready.
Let's scroll up for a second.
Yeah, what's
What's
up?
the other one you did?
This one was where the bottom was
I'm
bigger.
actually about it, yeah.
What, oh, so we don't have the one where it's like, it's not. Oh.
No, this was the one I gave you on the test, which didn't cover every version. I'm saying look at
For
the old
finals,
for the
that's
the final.
that's
Everything's
enough.
no, everything's free game. All right, log stuff.
But like,
Evaluate logs.
it's enough.
So in this case, we put x over here. Remember, to get rid of a log, base log, you made a base exponent on both sides. So we're going to rewrite that as 64 equals 2 to the x power. And then, how do we get rid of... So we ask ourselves, 2 to what power gives you 64?
3, 6.
6. So it's going to be x equals 6.
No.
This one, log 12 base equals x. In this case, again, base 12 on both sides. So 1 equals 12 to the x power. What would cause anything to become 1? What power, I should say?
0.
0. So this one's x equals 0. This one, same concept. 1 over 81 equals 3 to the x power. Now, 3 to what power would give you just 81? Let's start with that.
3, 9, 4.
4 would.
So 1 over 4.
So it's going to be negative 4 because negative exponents is what brings them in. I'll put one of the fake answers as 1 over 4, okay?
This is not everyone's problem.
This one, it's going to be 5 equals 125x. In other ways, you could think about it, 5 to what power gives you 125? This would be, in this case, 1/3. So x equals 1/3 because it's a cube root. The cube root of 125 is 5.
Are we just supposed to know that?
How you could think of it is like, notice how this one's a smaller one? So you could think of like, how do I do this, right? Or, if you really want to, you set this as 1 and rewrite this as 5, 3x. And then just do 1 equals 3x. That's another way you could do it.
Yeah.
And you have your calculator throughout the whole time. So if you know the change of base formula, which is log A, or I guess base is always B, log B A, you could always rewrite it as log A over log B. Like that. So you could always type that in your calculator. This one, you can't type this one in the calculator because there are x's here. So, which is purposely why I did that way. So now this one you have to figure out. So log 45, I have to rewrite it in a way that's useful. In this case, it is the same thing as log 5
Jacob,
plus log 3 plus log 3. Because 3 times 3 times 5 is 45. And when you expand, you put plus signs for multiplications. I actually know what log 5 is. It's 0.774. I actually know what log 3 is. It's 0.528. I know what log 2 is. That's 0.333. Well, I don't need log 2, I guess, in this one. But in this case, I'm going to do 0.774 plus 0.528 plus another one, 0.528. And I'm going to figure it out. So in this case, I take my calculator and just do the math safely for myself. So 0.774 plus 0.528 times 2, because that's the same thing as just adding it twice, 1.83. Next one is division. Division tells you you're going to subtract log 3 minus log 5. Technically, the questions have little x's here, but yeah. Log 3 over log 5. So that means I know what log 3 is, 0.528, and I know what log 5 is, 0.774. So 0.528 subtracted by 0.774. Negative 246. Okay. Next one, expanded logs. So this is going to be log 100 plus log x minus log y. Division is subtraction in the same way multiplication is addition. But log 100, remember it's a divisible 10, can be simplified. 10 to what power gives you 100? 10 to the second power gives you 100. So it's going to be 2 plus log x minus log y. So it's a multiple choice question. In this case, this is how the multiple choice answer would be if this was a question. For this one, it's going to be 3 ln x, because exponents go in the front, plus 5 ln y, minus, this is 4th root a to the third. That's the same thing as a to the 3 over 4 power. So I'm going to do 3 over 4 ln a. That's it. All right, this one, you're condensing logs, so this is a reverse of expanding logs. For this one, it'd be log, the numbers in front goes on top, x to the third, y to the 6, over a to the second. Because it's subtraction, we divide.
If it doesn't give you one, it's log 10, right?
Say it one more time.
If they don't give you like the little thing on the bottom.
It's 10, yes. This one, ln 9 to the half power, that's the same thing as square root. So that's ln 3 divided by 10. And to be clear, this is different than this. Notice here the 10 is divided by everything, while here it's ln 3 10 inside. Would I put that as a fake answer? No, that is not correct. Well, I'll put that as a fake answer, okay? Next one. Solve for x, leave in terms of ln and e. So in this case, well, I'm not even asking you to evaluate, just giving you ln and e's. So I need to get rid of the e. So the best way to get rid of e is to log both sides. Log base e has a special name, ln. So it's going to be 23x equals ln 40. Then I divide 23 on both sides. So in this case, this one is ln 40 all divided by 23. No, because it's just in terms of ln and e. So this is how it would look like in the option. This one, e's are here and here. So it's 3x equals x minus 12. No. So we're going to divide and solve. A little bit of algebra. X equals 6. Negative 6. Next one. This one, you have to make them the same base before you can cancel them. So I'm going to change this to 2 to the third. X minus 1. And I'm going to change this to 2 to the fifth. 2x. So this is going to become 2 to the 3x minus 1. Or 3x minus 3, my bad. Equals 2 to the 10x. You can cross out the 2's. So it's just 3x minus 2 equals 10x. A little bit of algebra. X equals negative 2 over 7. Yes. Next one. Remember, it's divisible 10 if you don't see anything. So I'm going to bring the 10 to the other side. So x equals 10 to the fourth power, or 1, 2, 3, 4. 10,000. Yes.
When's the final? It's not on Monday, right?
It's Wednesday.
What do we have on Monday? English?
It's normal. It's just a normal school day.
Oh, so you're the first final?
Yes. Next one.
I know.
I'm going to take the 2, bring it over here. So square root of x equals 2 to the third power. So that's the square root of x equals 8. Square both sides. X equals 64. Next one. Before you cancel out logs on both sides, they only could have one log on both sides. So some people forgot this on the test. You actually have to combine like terms, or you have to condense. So ln is going to be x squared plus 8x equals ln x minus 12.
Burger spot.
Yeah.
Yeah.
Burgers parks in the senior spot.
No, your car parked in like the one that
I
has
was
a
in the car.
sign.
I was in the car.
So your dad drove. You guys drove.
My car's
Wait, hold on. No,
right there.
you have the purple minivan.
No, that Lexus.
Whose purple minivan?
My Lexus gone.
So which is
Next,
yours?
next.
So we're going to rewrite this to set it equal to 0.
Your dad actually drove something.
X squared plus 7x minus 12 equals 0. So things, wait a second. Oh, plus 12.
She's a hot one out here.
Yeah. Okay. So then it's x plus 4, x plus 3 equals 0, which means my possible answers are negative 4, negative 3. Now, with that in mind, with a log question, you cannot have a negative within a log. So in this scenario, neither negative 4 can't work, nor negative 3, because if I plugged it in here, it would become negative. And thus, this will be a no solution in this version.
Also, the kids that don't have a car, they're at least going to drive to school 3 times a week. Like, Sam, how often do you have a car?
This one we're going to combine. So it's log base 2, x squared minus 2x equals 3. Now I need to get rid of the base log 2, so I do everything rise by 2. So x squared minus 2x equals 8. Subtract 8 on both sides. X squared minus 2x minus 8 equals 0. So in this case, it's going to be x minus 4, x plus 2. So it's positive 4 and negative 2. Remember, there's no way, think of it like this, there's no way I could put a exponent that causes it to be negative. There's no exponent that could cause that.
Because that's eyes, right?
Not even eyes would solve that problem.
No,
Or
I'm saying like negatives give you what?
not in the way you're thinking of. That's something else. But either way, that means -2 is not a option. So in this case, the only answer is 4 in this case.
So any negative.
You can because there's a plus sign in between. And when you do, you multiply. Some people just added
have a
it.
negative answer, right?
You can have a negative, or you can have a number that causes a negative in a log. So if you had something like log, let's say
So
x
what
plus
negative
3,
would you allow?
technically -1 would be okay.
How?
Because if I plug it in, it's -1 plus 3, which is 2. It can't cause a negative.
-2.
-2 is a problem because this is just x. So it'll be log 2
Oh,
-2,
okay.
which is a problem.
Yeah.
All right, next. Oh, no, this is still the same test. Wow. This is a big test.
Yeah.
Next one. Log.
Take some self-love.
Log for this equation, 0.6 x minus 3 plus 1. Describe the transformations. So in this case, this is the h value. So I'm going right 3 because remember, you got to flip the sign for the h. You're also going up 1. Okay? Is it a growth or decay? 0.6 is less than 1, so it's a decay. Graph. I recommend plugging it into your calculator and solving it. In this case, it would just be, if you plug in 3, that would cause it to be to the 0 power. So 3, 1, 2, 3, 1. It'll be like this, and it'll look something like this.
Yeah. Did you have a baby? No, yeah, right, yeah.
Next one, a log graph is going to be 3 ln x plus 1 minus 2. What is the transformations? So in this case, it's a vertical stretch by 3. It is left 1. And it is down 2. Graphing ln x, if I were to plug in 1 into the equation, anything you plug into, or if I were to plug in -1, that would be 1 over here. So that would be 3 minus 2 is 1. So -1, 1. And then I'll graph from here. Or actually, it should be like, I think it's actually here. Either way, I recommend just go into your calculator, click second table, type it in, second table, get the values. Let me do that for this one just in case. So y equals 3 ln x plus 1, parenthesis minus 2. So I'll graph it. Oh, that's a little bit off what I drew.
Are we gonna have to graph or is that or is
That's
it
the
graph?
open-ended. 0, comma, -2.
That's the only
Oh, I reversed the situation. Yeah, I messed up. Okay, even me, I make mistakes. Go figure. 0, comma, -2. 1, comma, a little bit this. Something like this. Wait, what the? What is that error? That's interesting. Whatever. All right, next one. This is a What?
It's all one test.
It's one final. I'm just doing the next one.
How many questions are going to be on the final?
When I finish, I'll tell you. So change 330 degrees to radians. So remember, 330 times pi over 180. Since I'm going to radians, you put pi on top. So that's going to be 11 pi over 6.
Okay, so
5 pi over 6 times 180 over pi. Simplify when possible. Pi's cross out. Cross this to 1. Cross this to 30. 5 times 30 is 150 degrees.
how about
Next one. Sine pi or sine theta is 5 over 13. What's tan theta? So if I had an imaginary triangle where this is a theta over here, opposite 5 over the hypotenuse 13. I'll have to find the adjacent, but that's a 5, 12, 13 triangle. You could always use Pythagorean theorem to figure it out. In this case, I want tangent. Tangent is TOA, or opposite over adjacent. So I know tan of theta equals opposite over adjacent, 12 over 5. Next one. If cosine is 3 over 5, what's cosecant? Cosine is 3 over 5, so you have a right triangle like this. So your theta would be here. This would be adjacent over hypotenuse. Oh, over hypotenuse. So this is 3, this is 5. This one's a 4. I need to find cosecant. Remember, cosecant is the reciprocal of 1 over sine. So instead of being opposite over hypotenuse, it's hypotenuse over opposite. So it's going to be 5 over 4. Next one, solve for theta. For this one, I have an adjacent and I have a hypotenuse. So it's cosine theta equals adjacent 6 over hypotenuse 9. So I do theta equals cosine negative 1 6 over 9. Which means I literally have to finish this. So cosine. So it's going to be cosine 6 over 9, which is going to be 48.2. So 48.2. Since the answer is in degrees, make sure your calculator is in degrees in this situation. Especially since we're talking about an actual angle of a triangle. Next one. Give positive and negative coterminal angles to 4 pi over 3. So coterminal angles are in the same position. They're just full rotations. So if I start at 4 pi over 3, I could add a full rotation. A full rotation in radians is 2 pi. But since it's divided by 3, I have to add it with the same denominator. So 6 pi over 3. So my first one is 10 pi over 3. If I want a negative one, I have to subtract 2 pi. So it's 4 pi over 3 minus 2 or 6 pi over 3. So it's going to be negative 2 pi over 3. Okay. So those are two coterminal angles. A reference angle is based off what quadrant it is. So in this scenario, 7 pi over 6 would be in the third quadrant. So this is going to be 7 pi over 6 minus pi. Usually we turn in degrees in 180. I'm just keeping it on radians on purpose. So 6 pi over 6, which means the reference angle is pi over 6. Reference angles are the angle that is just between here and here. So that's a reference angle because that matches the same angle over here. Coterminals, like I could wrap around, I'm literally in the same spot. It's a full rotation. To describe it a little bit better, Sam, I could throw my phone 45 degrees this way or like this way. But a coterminal angle would be doing this and then spinning 360 and throwing it in the same spot.
Why are you adding 6 pi over 6? I need a cup.
It's subtract.
Why?
Because this would be in this one, it'll be theta, or I'm sorry. Yeah, theta minus 180. Because it's in the third quadrant.
So if it was in the second, it would be 180 minus theta.
Other way around, 180 plus theta. Oh, no, 180 minus theta. You're right.
Okay, fine. Okay. Josh, are you moving up?
Next one. If a 20-foot ladder is leaning on a house, the bottom of the ladder is 50 feet away at the bottom of the house. What's the angle of elevation? So in this one, you have a house. You have your ladder. I know the ladder is 25 feet.
You know the distance is 15.
And I know the bottom of the ladder is 15 away. What is the angle of elevation? So that's how much it's looking up. You're elevating. So is the angle of elevation. So this is adjacent. This is a hypotenuse. So cosine theta equals 15 over 25. I could also simplify it. So theta is cosine negative 1, 3 over 5. That, if you type in your calculator, should be 61 degrees or 69 degrees.
You remember that?
I do a lot of 3, 4, 5, so yeah. No, it's 53. What the heck? I wasn't even close. 3 over 5? Yeah. 53.1.
You're all missing the problem.
Degrees.
No, they already know we're all here.
That window could be opened.
I think they have money.
I'm gonna run them over.
What are you doing? Walking the street?
So look up. Guys, he's doing this for you. You guys should make it.
All right, next one.
Put that song on.
Guys. Shh. Yeah, Sean. Sine. So sine theta is 0.6 comma negative 8. So I'm going left 6, up 8. So I have a line right here. Put a theta here. So I know it's went 6 to the left and 8 up. You can find the hypotenuse, which is 10. If you did the math. So it's negative 6, 8, 10. So in this case, I want sine of theta at 0.68. So I want the opposite, which is 8, over the hypotenuse, which is 10. So your sine is a theta is, to simplify, 4 over 5. Next one. Find tan theta given that cosine is 12 over 13 and sine is less than 0. So in the quadrant, sines are negative. So for this one, sines are negative in quadrant 3 and in quadrant 4. And over here, cosines are positive in quadrant 1 and quadrant 4, which means the place we're looking at is quadrant 4. So, cosine is adjacent over hypotenuse. So, if I have my theta here, adjacent is 12, your hypotenuse is 13, which means over here, you're missing your right angle, your y value. But we know our 5, 12, 13s, so this is negative 5. With that in mind, I want the tangent. Tangent is opposite over adjacent. So negative 5 over 12. For this one, yes. You could do this. All right. This one. Evaluate tan pi over 3. Pi over 3, if you know your unit circle, is the same as 60 degrees. Tan at 60 degrees is sine over cosine. At 60 degrees, sine is root 3 over 2 over 1 over 2. Simplify the 2's here because they're both on the bottom. Your answer is root 3. Next one. Evaluate sine 225. So sine 225 has a reference angle of 45 degrees and it's in the third quadrant. It's in the third quadrant. So I know because it's sine, it should be negative, and because it's 45 degrees, it's root 2 over 2. So it's negative root 2 over 2.
I know this.
Doesn't matter. He's doing this for you.
No.
Next one.
Wait, can you go up a bit?
That's why we have a video.
First one. What's C11?
Cotangent.
You're good.
Don't you forget it.
Well, but
Next
we're gonna
one.
give the combined gift.
Good.
He got in the.
Are we gonna have
No, you always get a new teacher. So it's you, Reese or Kirsten.
You did 138.
Cotangent pi over 4. So this is the same thing as pi over 4.
Missed the problem.
Tangent
Yeah, it was so cute.
of pi over 4. Guys, pi over 4 is root 2 over 2. But this is cotangent, so I want the reciprocal. So cotangent of this is going to be 2 over root 2, which, if we rationalize it, will be root 2.
For you, accelerated.
What is the 2 root 2 over 2?
Yeah, but then you could cross out the 2, so it'll be root 2. And since it's a multiple choice question, it will look like root 2. All right. This one, cosine 17 over 6. Now, here's the real hint. Because it's a pi over 6, you know it's going to be a 30 degree or a pi over 6 angle. So cosine of pi over 6, aka 30 degrees, cos of pi over 6 or 30 degrees, guys, is going to be, since it's pi over 6, that's short, so that's going to be long, so that's root 3 over 2. Now, 17 pi over 6, we need to know what quadrant that is. So, this is not within 2 pi. So I'm going to have to subtract 2 pi from it. So 17 pi over 6.
But don't you know that it's in the fourth quadrant? It's not in the fourth quadrant.
I mean, we want to know what quadrant it is.
Right?
Well, let's see.
Cosine's positive in the fourth quadrant.
Oh, I don't know if it's positive or negative yet. I just need to figure out the quadrant. That will tell me the positive or negative later. So first, I just know it's going to be root 3 over 2, whether positive or negative.
Okay.
Like your options here, I would put root 3 over 2, negative root 3 over 2, positive half, negative half. So it's going to be 12 pi over 6, which is 5 pi over 6. If you convert that to degrees, that's 150 degrees, or quadrant 2. So that means this is going to be quadrant 2. Cosine's negative in quadrant 2. So negative root 3 over 2.
If I draw the unit circle on
That's
the,
no
on
problem.
The final, no. But if I draw, can I actually have it?
No,
Entire unit circle with everything on it.
that's for your benefit.
No,
Yeah, why does he get?
Exactly, benefit of 5 extra points.
Wait, why is it pi over 6?
We'll talk.
Why is it a pi over 6? If you can't simplify this anymore, it's automatically a pi over 6. That's a hint to the radiant thing.
So wait, so it's like, I don't know, like 19 pi over 3 would be pi over 3.
Yeah, because you can't simplify it. Just be careful though, because it's like you might say something like, let's say 20 pi over 6. And you're like, oh, that's pi over 6. No, you can simplify that to 10 pi over 3. So that would be a pi over 3 in that situation. All right, next one. What are two values of theta that could happen that sine is root 3 over 2? Sine is root 3 over 2 at 60 degrees, or otherwise, pi over 3. So pi over 3 is where it could happen. Where else, if it's positive, it has to be in the second quadrant, because sine is positive in the second quadrant. So 2 pi over 3.
Oh, so I have.
How do you know that?
Why is it in the second quadrant, or why is it 2 pi over 3? That is going to be 120 degrees.
Oh, I think you add 2 pi. Pi over
Yeah.
3 plus 1.
Or you could do 180, or not 180, pi minus pi over 3.
Okay, and
Or you could think of it as 180 minus 60 would be 120. Okay. Do we have more?
Now we have a minute left, not even.
All right, I'm going to cut it off here. Do we have knife here tomorrow? Yes, we do.